I do want to focus on the end of 2021 and 2019 FRQs. The reason why 2020 is skipped over because 2020 was COVID year, and that year AP exam was a little bit different. It's like only 2 problems, 40 minutes. So that was an off year. So there's no released AP exams for 2020. So hopefully you guys, when you guys came in, you guys picked up this exam detail handout. And then right below it, if you weren't here yesterday, have packet 6 along the worksheet and the packet and the key. So if you don't have any of those, I can go and pick those up. Just want to highlight a few things. I think I've gone over this before, but just to kind of highlight and make sure we know that you're going to start off with multiple choice, 45 questions, hour and 45 minutes, 30 questions, 60 minutes, non-calculator. And then right after that, you'll bring up your calculator for 15 question, 45 minutes test. And then you'll have a 15-minute break, and then you'll take your FRQ, 2 questions, 30 minutes for the calculator portion. And then after 30 minutes, you'll put your calculator away and you'll do the remaining 4 problems, 1 hour, no calculator. But you can still work on 1 and 2 just without a calculator. Let's see, I wanted to highlight. Yeah, I think, I think it's good if you guys can read through this. I do think this is a helpful thing that when you get your multiple choice test, the non-calculator portion, go ahead and spend just a minute to do this real quick. Write down your 6 straight derivative rules at the top of your multiple choice test, because that's going to be where, if you have any derivative rules, integral or derivative, that's where it's going to show up. It's going to show up. So I think it's really helpful to write those 6 rules. And what I mean by that are these rules here. So on page 8, I have page 7, I have the key here. So this is what I mean. Write these 6 rules down at the top of your multiple choice test. It'll come in really handy because, especially for the integral rules, because I don't have integral rules memorized. I just have the derivative rules spelled out, and I know I can work backwards from the derivative rules to get to my integral rules. Right. So I think it's worth your time spending a minute, write down those rules at the top of your multiple choice test, non-calculator, and at least 1 or 2 of them will show up over the course of your multiple choice test. Okay. I also included in here. Yeah, maybe I'll highlight some more things along the way, but I also included a blank practice sheet for all your derivative rules, so that you guys can see if you can recall them, and also the keys for the derivative and integral rules. Derivatives is on 1 page, integrals on the other, and I just have some various practice sheets for your rules. And I included here page 11 and 12. I think are, if I could condense all of these topics into a cheat sheet, this is what I would do on page 11 and 12. So I think it's worth your time looking through this over the course of this week and next in preparation for your AP exam. Okay.
Are we given any formulas in the test?
The only formulas you're given would be volume of like spheres or cones or cylinders. That's it. That's all you're given. In terms of formulas that you should know besides your derivative rules, make sure you know area of a rectangle, area of a square, area of a circle, circumference of a circle, and trapezoid area. Okay, so those are the ones we've been practicing with, and those are the ones that most likely they won't give you. Sometimes maybe in some cases they would give you an easier geometric formula, but typically I think we should know those. But cones, spheres, they'll give those formulas to you.
Is there any chance for like one of those shadow problems?
Yes, those shadow problems, they have shown up in the past and they're in packet 6. So we can go over them over the course of next week if we like. Yeah.
Did you use pen on the FRQ? Did you use pencil?
Oh, right. Yeah, you can use pen. But for your multiple choice, make sure you use a number 2 pencil. So bring a number 2 pencil. But yeah, if you want to use black or blue ink, you can use that for your FRQ. Yes. Yeah. In fact, maybe it is yeah, it's because now they're when they're grading now, they're scanning all the tests and all the tests are graded on computer on the monitor screens. So so there is a argument for black and blue ink because it just shows up better. But whatever you're comfortable with, that as long as you write out your answers clearly and that you don't use if you use pencil, just make sure that you don't use faint mark, that you're writing it boldly so that when it gets scanned, that it doesn't come out as where it's difficult to read. Okay, good. Any other questions that you guys have? Okay. I feel like I want to work on one specific problem from your packet 6. So if you guys can just grab your packet 6, I just want to go over one specific type because it's shown up on the multiple choice test, and I don't know if I really spent enough time going over these. It's not difficult, but it's just maybe you haven't quite seen these forms yet. So this is on page 63. I want you to just make sure that you're familiar with these specific types of problems. I feel like I want to do it today because I feel like next week the classes will, my class size will be even smaller because of AP exams. But while I have most of you here. Okay, so here's the question, page 63. It says the function e to the 3x minus 5x is a solution to which of the following differential equations? So ultimately, we're not going to find the derivative and match up one of these. I think it's easier path to do is let's go ahead and find y prime and y double prime and see which one, if we insert it back into our answer choice A through D, will end up looking like that. Right? So the way that we approach this, let's just go ahead and find y prime and y double prime, so we can use those to work for A and B. So if I'm trying to build y prime off of e to the 3x minus 5x plus 7, what's the derivative of e to the 3x? Yeah, e to the 3x times 3. Yeah, e to the u times u prime. Okay, so we keep going. Minus, what's the 5x becomes what? Negative minus 5. Okay, so here's my derivative, which is 3e to the 3x minus 5. Okay, so I know I can use that to substitute and see if I can plug in and get to that choice there. What's y double prime going to be? What's the second derivative off of this? Yeah, 3e to 3x times 3, which is 9, right? So I have another coefficient that comes out of it. So 9e to the 3x. What happens to the 5? Goes 0. Okay, so we know we're playing with these. We're playing with y prime. We're playing with y double prime. And we're just doing trial and error, right? Trying to plug in and see, okay, which one, if we plug in, we can eventually get it to look like. Okay, and the idea is that not necessarily that we're plugging in and trying to get up to this equation. We want to be able to plug in and actually get a true statement, Right? That means if I replace y double prime with 9e to the 3x, if I replace y prime with 3e to 3x minus 5 minus 15, is it going to end up being a true statement? Is it going to ending up is it going to end up zeroing out? So let's just try part A here. So I'm going to replace y double prime with 9e to the 3x minus 3 times y prime. My y prime is 3e to the 3x. And then minus 15. Okay, and then we just clean that up. If that's a true statement, then that's our answer, right? So 9e to the 3x, distribute the negative 3 through. Right, does that end up being a true statement? Does everything cancel out to be 0? Yes. Okay, so that's our answer choice there. Okay. And for choice A. I've mixed in here solving differential equations, so I'm going to skip 1. I feel like we know how to do that. Cross multiply, y is on the left, x is on the right. Take the antiderivative. Okay. So you guys can try that. I just wanted to do another 1 or 2 of these types of problems so that. Let me see. Let's try number 6. How's that? Number 6, and then we'll go back to FRQs. Page 66. For what values of k is y equals e to the 2x plus k e to the negative 3x a solution to a differential equation? Right. So again, the idea that, okay, let's go ahead and find our y double prime so that we can plug in and then hopefully eventually solve for k. So whenever we see that y prime or y double prime within our problem, let's go ahead and find them. And then if we can find them, we can use those as substitutions to move further into our problem. So we know we have to move to y double prime. So let's start off with y prime. Y prime is just the first derivative of that. Okay. Okay, so what's y prime going to be? E to the 2x becomes
2x.
So e to the u times u prime, right? So e to the 2x times 2. What's 2x's derivative? 2. Yeah, so 2e to the 2x, right? Okay. Plus, k is just a constant, so there's no product rule here. It's just some number that hangs out in front. So what's the derivative of ke to the negative 3x? Good. So the e to the negative 3x produces e to the negative 3x times negative 3. And that negative 3 will just come out in front of the k. So like you said, minus 3k e to the negative 3x.
So the k stays here.
Yeah, the k stays there. K is just some unknown number. It's just like a 3 or 5. We just don't know what that number is, but we'll treat it like a constant. There's a mention of y double primes, right? So let's just move to y double prime, so we can use that and plug in. Okay, 2e to 2x becomes what? 4e to the 2x, right? Okay. Okay. 3k e to the negative 3x becomes
9k.
good. So another negative 3 comes down. The 2 negative 3 becomes positive 9. Okay, so we're going to plug everything into our second equation. And the hope is that once we get everything in terms of x's and k's, we can solve for k. All right, so we're going to replace y with what? Yeah, the original equation. And then we can replace y double prime with what we built here. Yeah. So there's no need for y prime for this equation, but we do need to get to y prime to get to y double prime. So it is just kind of like a stepping stone for our problem. Okay, so I'm just going to put everything into this equation and then see if that will help me move forward towards isolating and solving for my k value. Careful here. There's a minus sign in front of the y double prime, so we do need to protect that y double prime with a set of parentheses. Otherwise, we may forget to distribute that negative through. Okay, so now we have everything in terms of x and k. We should be able to clean all this up and then move towards solving, combining some like terms, and then just solving for k. Okay, bunch of like terms here. Let me combine all these together. Then I can put the k terms together. So 8 minus 4 is 4. 4 minus 10 is -6. Oh, I'm sorry, guys. I copied the wrong thing. I said y, but I put down y prime. My bad. I should have put the y instead of y prime. That's not what the problem says. Sorry, let me. Okay, let's try again. Copy something wrong here. Okay, so the 4e to 2x, -4e to 2x, that cancels out. That just zeroes out. I'm just left with 4 minus 9. These are like terms, so this become -5k e to the -3x. That negative exponent, I know, feels a little bit strange, but it's nice that we can just cancel these out, right? Because we know that 5 e to the -3x, e to the -3x, I can just divide them out. So I'm just left with the easy equation to solve. -5k equals 10. Solve for k, divide both sides by -5, k equals -2. Okay, so that's the strategy with these problems. If there's a mention of y or y prime or y double prime, go ahead and find those derivatives, and then you're just substituting them back into the equation, and then either confirming that it's a true statement or trying to find a missing value. So that's the same thing that we do with number 7. We build y double prime, plug y double prime in, and then solve for k. So we haven't quite seen a problem like this before, but it's not difficult as long as we know, oh, so find a bunch of derivatives and then make a bunch of substitutions after that. Okay. All right, we're gonna shift our focus to packet 6 early next week once we get done with packet 5. But let's go back to packet 5 here. Let me just run through 2021, 11, page 11 and 12. These are non-calculator. This is homework from last night. Again, it says show that dy dx equals. So anytime you see the word show, that means you're starting with this and you're getting to that, right? And hopefully we can see this and recognize, okay, there's power rule involved, implicit involved, product rule involved, because that y sine of x, we got to go through f prime g plus f g prime. So it's a tedious process, building each of the derivatives and then solving for dy dx. Right. But the nice thing is they tell you what the answer is, so you know what to work towards. So I like these problems for students because it's like, okay, even if it's complicated, you know where you're going to end up, and that makes it easier to kind of help you through your steps. Part B, write the equation for the line tangent. So we know tangent line is order pair and slope. Even if you couldn't get part A, you could start off with this, right? They give you the derivative. So, okay, plug in that order pair into the derivative, get your slope. Once you get your order pair and your slope, do point slope form, and then there's your equation. Okay, I think we are pretty good with that. Part C, find the coordinates where the line tangent to the curve is horizontal. So horizontal tangent means where the what of the derivative is equal to 0. Where do we look horizontal tangent versus vertical tangent? Horizontal tangent, we set the numerator or denominator. Numerator equal to 0. If we're looking for vertical tangent, then we're going to set the denominator of the derivative equal to 0. Okay, so we're going to set the numerator equal to 0. Y cosine of x equal to 0. We know y is a positive number, so we can just cover that up, solve for x. We get cosine of x is 0. That's a unit circle value. That's pi over 2. And then we plug that back into the equation, solve for y. Once we solve for y, then we can find that order pair. Part D, determine if there's a relative max or relative min. And to do that, we're not going to create a sine line here. That's difficult. So what they're trying to get you to do is to find the second derivative and determine if the second derivative is positive or negative, and then from there determine whether we have relative max, relative min. And this is one that I just had trouble believing that this was on the test. This is such a this is not normal. Okay, having to do quotient rule, and then within quotient rule, having to do product rule, and within product rule having to do implicit. This is, I just want to let you know, I don't like, this is the most tedious problem. Typically AP exam, they don't do this. They don't see how complicated a problem can be, but this is one of those instances where I think it's good practice for us, but I think this feels a little out of the norm in terms of FRQ problem. So we go through the whole F prime requires a product rule inside of it. And then after that, we plug in our order pair that we've gathered to determine if it's positive or negative. So this is a important thing here. If we can determine that a second derivative value is negative, that means my graph is what? Concave down. If my graph is concave down, then there must be a relative what at that slope 0? Relative max, right? Because we know what the shape of concave down is. If you pair concave down with slope 0, the conclusion that you can make is that there must be a relative max there. So I think that's the big thing that I want us to take away from that. And you know, like that's just I think that's a difficult thing to have to do, and we didn't really practice a whole lot with these types of problems because we just don't ever see these types of problems. Okay, let me just run through page 12. This is one that we have to solve a differential equation. But first, we just sketch the solution. Sketching a solution is really just sketching the graph through those points. Use separation of variables to solve differential equation. We can cross multiply. We can separate our variables, get our y's on the left, x's on the right, solve for plug-in order pair, solve for c, and then solve for y. So we've seen a lot of those. So hopefully that feels pretty straightforward. And then part D again, second derivative. So it says, is the rate of change increasing or decreasing? So there are some keywords there. Is the rate increasing? So rate of change is first derivative. If you're talking about increase or decrease of the rate of change, then it's the second derivative. So we have to go through, in this case, quotient rule, implicit again, shows up in the back-to-back problems here. And then once we get to the second derivative, we plug in our order pair and we look at that number. Because we see a negative second derivative, we can say that the rate of change is decreasing. It's a lot of second derivative implicits in one AP exam FRQ. Okay, if we can spend our efforts on page 15. And this is one of the predicted problems that I think will show up on the AP exam. This is a rate in, rate out problem. So let's look at this here. So fish enter lake modeled by E of t. So E of t represents the rate at which fish is entering the lake. Fish leave the lake at a rate modeled by L. So we have another rate that represents the rate at which fish leaving the lake. Both E of t and L of t are measured in fish per hour. So they're both rates. And t is measured in hours since midnight. Part A, how many fish enter the lake over the 5-hour period? Okay, calculator question. So we have E of t. This is fish per hour. So how can I get from fish per hour up to the number of fish? Take the what? Antiderivative, right? That's allowing us to strip away that denominator per hour if we just take the antiderivative. Okay, so part A is pretty straightforward. We take the antiderivative of E of t from where to where? 0 to 5. Yep. So we just plug that in the calculator and we just round to the nearest whole number. Okay, so we math 9. Plug in E of t into your calculator. 20 plus 15 sine pi t over 6. Part B says, what is the average number of fish that leave the tank over the 5-hour period? So what does that remind you of? Average number of fish. We got to use what? Average value theorem. Yep. So again, I think it's pretty straightforward. If you know what that formula is, you're just putting it into your calculator. 1 over b minus a integral from a to b of L of t. So now we want to find the average rate, not fish entering, but fish leaving. So our units is going to be fish per hour. Part C, at what time from 0 to 8 is the greatest number of fish in the lake? So a lot of stuff going on here. First off, greatest number of fish, what does that remind us that we have to apply? EBT, right? But there's going to be quite a few things that needs to happen before EBT. We have to first find critical points, and then from critical points, we got to build that formula. So the formula that we're going to eventually use is this rate in, rate out formula. If I want to find the total amount of anything, I got to consider three things. How much is there to begin with? How much has been added? And then subtracting how much has been removed. Okay. So we have those three. Let's see, do we have? Okay, so we have all three factors still. In this case, there is no fish in the lake to begin with. And then we have A of t that will tell us the amount added, the number of added, and then we have L of t. If we take the integral of that, that will give us the amount removed. So I'm starting off with that formula here. So number of fish is f of 0, which in this case is 0. There doesn't happen to not be any to begin with. And then if we take the integral of the rate at which fish is coming in, that'll tell us the number of fish that's entered the lake. And then the integral of L will give us the number of fish that's left the lake. So we know that if we want to do EVT, we have to first find critical points, right? Test critical points and endpoints. And to find critical points, we set the derivative equal to what? 0. Yeah. So to find the derivative, we have to get this down to the derivative level. So we know f of 0 is just some number. We know that number is 0, and the derivative of 0 is still 0. And the derivative of integral of e will turn into just e of t. And the derivative of L of x will turn into just, the derivative integral of L of x will just turn into L of x with that t. And so we just basically, if we find the derivative, the derivative is going to just strip away the integral notation, and we're just down to those functions, e of t minus L of t. So this is how we're going to use our calculator. We want to find when our derivative is equal to 0. We set our derivative equal to 0. So we're going to graph e of t minus L of t, enter all this mess into your y1, y2, or y3. If you want to do y3 equals y1 minus y2, and then just make sure that you don't see the graphs for 1 and 2. Graph it, and then look for the x-intercept. Okay. You know that you can set your bounds between 0 and, wait, let's see. Oh, yeah, you can set your bounds between 0 and 8. And then the numbers are in the teens. So maybe you want to set your window y value from like -20 to +20. But you can always play with those numbers. But either way, that x-intercept will get you to 6.20356. There's only one critical point. So then you're going to test f of 0, f of 8, and f of 6.023. So f of 0 is 0. F of 6, if I plug into this formula, I'm going to get 135. If I plug 8 into this formula, I'm going to get 80. Between 0, 135, and 80, 135 is the largest, so that's my absolute max. Okay, we'll see a few more of these types of problems from 2018, 2017, 2016. So hopefully after a few more of these, you feel like you've seen it multiple times, and if it shows up on the AP exam, you kind of can predict what your next step is going to be. Okay, part D, is the rate of change increasing or decreasing? So this is talking about what? Rate of change is at the E of t and L of t level, right? So increase, decrease of that will be at what? Yeah, E prime, L prime, which if F prime is at the E of t and L of t, then F double prime will be at the E prime, L prime. So if we want to find the whether the rate is increase, decrease, we're basically moving on to the second derivative of F, which is really the first derivative of E and L. So part D is actually, I think, if we know the formula, we just have to plug into the calculator. We do math 8 on E of t. We do math 8 on L of t. Plug in 5 for both. We get a negative number. So therefore, we know the rate is decreasing, and our units of measure is fish per hour squared. Okay, let's do 5 minutes of working through page 16, 2019 FRQ theorem. Velocity of a particle moving along the x-axis by a differentiable function. Justify why there must be at least one time in which v prime, the acceleration, is equal to 0. So we have v of t, but how can we guarantee whether v prime is equal to 0? So basically, what theorem are they trying to get us to use if I'm trying to prove that the slope is equal to 0? Yeah, mean value theorem, or more specifically, we can also think of it as Rolle's theorem, right? So in order for Rolle's theorem to, mean value theorem is fine, but I just want to also mention that we can also mention Rolle's theorem. If I want to guarantee slope 0, what am I looking for with my y values? Same, right? If I can have the same y value, then in order for me to hit that point and then hit that point again, the graph has to arc up and come down, or arc down and come up. Either way, there's going to be a slope 0 along the way, right? So as long as I see the same y values, so here, if I go from 55 down to negative 29 up to 55, along that path, it's got to experience a slope 0. So slope, which is derivative of velocity, which is acceleration, we can guarantee that there is a slope 0, acceleration of 0, because we have endpoints that will be the same y value, which will change in y over change in x. If my y2 minus y1 are the same, I'm always going to get a 0 for my slope. Part B, use trapezoid approximation. So let's make sure that, I feel like these are easy points, right? So I hate to see students miss a trapezoid approximation because they forget a portion of the formula. So it's 1/2 width and then height 1 plus height 2. Make sure that you're doing the 1/2 as part of the formula. Make sure that you're adding the heights and that you're not subtracting the heights. Make sure that you're pulling the heights from the second row, and then your width is from subtracting your t values, right? 0.3 minus 0, 1.7 minus 3. Some students are adding the t values to get to the width. That's not right. So you're going to subtract the t values to get to the width, but you're going to add the heights to get the h1, h2. Part C, a second particle, Q, moves along the x-axis so that the velocity is given by v of t. So we now have velocity of a second particle, particle Q. Find the time in which the velocity of the particle is at least 60 meters per hour. So at least means greater than, right? Greater than or equal to. So I'm going to set that equation. I'm going to say v of q of t is going to be greater than or equal to 0, which means that I can bring everything over to one side and say v of t minus 60 is greater than or equal to 0. So that I can just graph this and look to see when it sits above the x-axis. All right, graph this expression and see where my graph is going to peak above the x-axis. And then I can find those x-intercepts. Once I find those x-intercepts, then I can use those as my bounds for my next part. Okay? Because we want to find the distance traveled by particle Q when the particle is at least 60 meters. So once we find those two t values, we just do our distance from one endpoint to the other under our velocity. So we just plug this in the calculator. We get 106.108. Okay, part D, we can use position equals initial plus displacement, and then use that to find the locations of both of the particle, P and Q, and then use those two positions to help us decide how far apart they are at a specific moment in time. Okay, so over the weekend, I'd like for you guys to finish up the 2019 FRQs. Next week, I'm still going to be checking FRQs on a daily basis, but I think I'll be using most of the class period to work on packet 6, and then just having you guys finish FRQs for homework from packet 5. All right, come get your phones. Thank you. Yep. Thank you. Thank you. Okay. If I say after school, but we don't do it, then follow class. Yeah, but it becomes very simple. 4 through 6, yeah. I feel better.